All right, so let's go down to the very last example, and then we'll kind of just do like a refresher on this stuff. And so make sure you have your calculators because you're going to want those today. And so here, we're told that there was 517 music teachers, and 403 of them said that those like music type video games, Guitar Hero and Rock Band, had a positive effect on music education. And so the first thing it's asking us are, what are the point estimates for P and Q? And so since P hat, so the point estimate for P is P hat, right? So point estimate for P is P hat. And do you guys remember what P hat is equal to?
X over N.
Mm-hmm. X divided by N. And so when it comes to the example that we're working on, which one of these, so we're only given two numbers. So which one of these is N?
517.
Yeah, it's going to be that 517. And so whenever you're doing a problem like this, regardless of if you're testing, if you're estimating a proportion or a mean, you're always going to be given N, right? And so the next thing you need to look for, especially when you're doing proportions, the next thing you need to look for is either you're going to be given X or you're going to be given P hat. And so you need to figure out which one you're given. And so here, am I given X or am I given P hat? Like, what is this 403?
X.
Yeah, that's X. So if you're ever given P hat, it's going to be given as a decimal or a percentage, right? So whenever you don't have that, it's going to be X. And so here you have 403 out of 517 responded positively, right? And so when you do this, oh, hang on real quick. So let's see what this is. 403 divided by 517. That gives you 70 or 0.779, which is about 70. Here, you would just leave it as 0.779. You can round it to 0.78. It's probably best to just keep two decimal points. That way things don't get overly complicated later. It will mean that our results are less accurate because the more decimal points you have, the more accurate your results are. But so that's the point estimate for P, right, is P hat. That's the number, that's the percentage of people in our sample that responded positively. And so now we need to find the point estimate for Q, which is going to be Q hat. But how do you find Q hat?
1 minus P hat.
Exactly. So 1 minus P hat. And so this is going to give you 1 minus 0.78, which I want to say that's just 0.22, right? Let me double check that. Yeah, it is. And so those are our point estimates. And so what we're going to do, so I'm kind of skipping ahead. I'm kind of skipping part B right now. But what you do with this point estimate P hat right here, this 0.78, is once you find your margin of error, this is what you add and subtract E to, right? But so yeah, just kind of keep that in mind. That's why you need to find the point estimate. But so the requirements, what's the very first requirement we need to check?
Random.
Mm-hmm. It needs to be random, and we're gonna pretend that it says random because it doesn't, but random, pretend that yes, it was random. Okay, so what's the second thing that I need to check for when it comes to proportions?
The N times P and N times Q hat.
Yeah, so N times P hat greater than or equal to 10, and also that N times Q hat is greater than or equal to 10. And so N times P hat, that's gonna equal, where did it go? Oh, N is 517, P hat is 0.78. When you do this, you're just gonna get that value of X, 403, and which is definitely greater than 10. And then n times q hat, that's equal to 517 times 0.22. And so that's going to give us, oops, times 517. I'm going to round that up to like 114 because you get 113.74. But either way, it's bigger than 10. And so both of these things together imply that the p hat distribution is normal. Okay, so are there any questions so far?
No.
Okay, so then to actually find the confidence interval for P, what we're gonna do is you can either do it by hand by finding E and then adding and subtracting that to your point estimate, but then you would also need to find your critical value. And so that's a lot of doing it by hand, but what in your calculator can you do? What can you use in your calculator? Oops. Which function? Where is my calculator? It's here. Yeah, one prop Z, but then is it going to be test or interval?
Interval.
Yeah, interval. So Madeline, you were right about the interval part, but we only ever use T interval when you are given a mean and a sample standard deviation. And so I'll do that recap in a second. But so yeah, you're gonna want to do one prop Z int, which if you go to stat and then test, it's like option A underneath all of the like 1 through 0. And then so you're just gonna put in, so this is one prop Z int because you want to find an interval. And so you're going to give it x is 403, n is 517, and your confidence level, what are you going to put in for your confidence level?
0.95.
Yeah, 0.95, not 95. And then you hit calculate, and it gives you the interval, oops, not negative, 0.74376, comma 0.81523. And it actually gives you the value of p hat right there. And so if you wanted to, you could use one prop Z int for part A also, because it gives you p hat. So do you guys have any questions up to this point? Do you guys remember what I was saying last time, right? That your confidence interval for proportions should always have numbers that are between 0 and 1, right? Because when I estimate this, I'm going to say, or when I estimate this, when I interpret this, we're going to say we are 95% confident that between, oops, 74% and 82% of, and then what kind of teachers is it? Yeah, music teachers specifically, of all music teachers think that those video games had a positive effect on music education. So think that Guitar Hero, etc., have a positive influence on music education. When are we supposed to be confident or unsure about the data? So when you're constructing confidence intervals, you're always going to be however percent confident, and that you're always going to say this part of it. We are however percent confident, and that comes from the percentage that you're given, right? So the only time when you're doing confidence intervals, you're always confident. It's just to which percentage are you confident, right? But when you're doing hypothesis testing, that's when you're going to have either like reject or not reject. And so we'll see how that fits in with the confidence level on Monday. So on Monday is when we're going to start connecting hypothesis testing with confidence intervals. And so that'll kind of answer your question. But for now, just kind of think about it as if we're always confident when we're doing confidence intervals. Does that make sense? Okay. So yeah, do you guys have any other questions for parts A through C before I do the very last part that's down here? So let's see. Oh, this question D is actually like a good setup for connecting hypothesis testing and confidence intervals, kind of. But so it says that there is a video game manufacturer, and they're claiming that 80% of music teachers believe that those video games have a positive effect, and it wants us to use our confidence interval to determine if that statement is true. So based on the confidence interval and the interpretation that we're given, is it unreasonable? Like, is it totally crazy to say that 80% of music teachers believe this?
No.
No, right? Because we found, and we're 95% confident, that's a pretty good level of confidence, that between 74 and 82% of music teachers think this. Since that 80% is in our confidence interval, that statement could be true, right? So here, since 80% is in our confidence interval, I'm going to put we are 95% the statement is true, or 95% confident the statement is true. Okay, so hopefully at this point, the most that you guys are confused about is when to use which calculator function. Because if you can understand the interpretations, and if you can understand the point estimate and the margin of error and how to calculate a confidence interval, then you should be okay. But you guys are really going to need to practice when to use which function. And so on my open math, I'm going to open up a 7.3 assignment. So here, let me make a little like, so on my open math, which is called mom, right? Get it? My open math. Anyway, so I'm going to make a 7.3 homework assignment, but then I'm also going to make an assignment where you just read it and you figure out which function on your calculator you're going to use. And so here, this is going to be chapter 8 and chapter 7 calculator function review. So this is like the first assignment and the second assignment. And then don't forget that exam 2 reopens on Monday. But so you should definitely take a look at these assignments. If you want to hold off on the chapter 7 homework for now, you probably can. I would focus on the exam over the weekend, right? Make sure you can get your grade up. But yeah, if you have any questions about it, you should definitely work on this assignment before then too, so that way you know if you're ready, right? Because this is probably where you guys are the most confused. Okay, so are you all done with 7.3? Are you guys ready to talk about the quiz? Oh wait, let me give you that recap.
Yeah.
So real quick, let me make this a little bit bigger. Here is the chapter 7 recap. And so this is if you're estimating, which is all about confidence intervals, right? And so you need to figure out, the very first thing you need to do is you need to figure out if you're given mu or if you're given p. If you're given mu, you need to figure out if you know sigma or if you do not know sigma. Here, you don't need to really worry about anything, right? You can just go straight to the calculator function. If you know sigma and you're doing a confidence interval, what function in your calculator are you going to use?
Z-test?
Not z-test, because we're doing this one. Yeah, it's going to be z-interval, but you are right about which like variable to use, right? So z-interval here. And then what about when you don't know sigma? What changes from this portion? Yeah, it's going to be t-interval instead. And then p we just talked about, that's one prop z int, right? So let's say that you wanted to do this by hand. So this is like the calculator way. By hand, each one of them gets their own method also, right? So here, what you're going to do is you're going to have E is equal to Z sub C times the standard deviation by the square root of n. Right, so I don't know if you guys remember that from 7.2. You guys will need to know this formula because I am going to have you calculate margins of error, right? Which also means you need to know how to find critical values. But so that you can study all of that in the homework, and I'm pretty sure there's some questions about it on the quiz, but maybe not. But then you do x bar minus E and x bar plus E, and that's your interval. So that's how you do it by hand. Here, when you do it by hand, you're going to have E is equal to T sub C times S over the square root of n. And remember, this T sub C is another critical value. It's similar to Z sub C, but that's the one that I told you you don't have to worry about finding, right? So I'm either going to, if I have you calculate margins of error here, then I'm going to either give you T sub C or tell you, like, I would give you T sub C. That's my only option. But here you do the same thing, x bar minus E, x bar plus E. And then here, E is equal to Z sub C again. So the same way you find it here, it's the same way you're going to find it here. But this time you have the square root of P hat Q hat over N. And all of that is under the square root. And then you're going to do P hat minus E, P hat plus E. And so you really only need to choose, are you going to do it, like if I ask you to find a confidence interval and I don't tell you to do it a certain way, you can either do it with your calculator or you can do it by hand each time. So you only need to pick one of these like boxes in each kind of flow chart, I guess. I don't know what to call this. Does this make sense though? So we just did all of chapter 7 in like 2 minutes. So one or the other. I hope I didn't just confuse you guys more. Does this help? Okay, cool. And then yeah, it's almost the same exact thing. So if I were to put in red what you would do when, or here, so let's just make another one, right? So I'll leave this up for a second, but the only thing that changes when you're doing hypothesis testing, actually maybe I can just put it in red. So hypothesis testing, which is chapter 8, while confidence intervals is chapter 7, right? The only thing that changes is instead of Z interval, you have Z test. Instead of T interval, you have T test. And instead of one prop Z int, you have one prop Z test. And you don't even need to worry about being able to do these ones by hand because I didn't show you. The only thing that you need to worry about doing by hand when it comes to the red parts is things like the critical value and what else was there? I think there was something else that I'm blanking on. Right? Oh yeah, the test statistic, and then maybe p-values, things like that, right? Critical regions. But so yeah. Okay, so are you guys ready to talk about quiz 6 then? Is anybody still writing this down? I don't want to move on if somebody's still writing this down. I feel like this is a lot. So hang on.